Okay, we're going to look at distributive property and common factoring. So we're going to try to focus on the common factoring, but we're going to talk about the similarities between these two methods. Okay, so we have f at x is equal to 3 times the bracket x minus 2. If we were told to expand, okay, if we were told to expand, that's when we're using our distributive property when we're expanding. And that's essentially going from, this is considered a factored form, factored, and for expanding, we're going to standard. So standard. Okay, and we know how to do this. It's essentially just distributing the 3 to both of the numbers inside, right? So we go ahead with that, and we get 3x minus 6. Does that make sense to you?
Yeah.
Okay, so now we're in our standard form, and let's pretend we didn't know the answer above, even though we obviously do. The question now says go from standard form to factored form. Okay, and in order to go from standard to factored, maybe use a different color here, we need to use a method called factoring. Okay, and we want to go to factored form. So in this case, we're not factoring a trinomial. This is just two terms. We're going to always first look for a common factor. So when looking at this, can you think of a number that is divisible? Both of the terms are divisible by?
3.
Yeah, exactly. That number that we essentially distributed in, 3 comes out. If you're ever unsure, one thing you can do is look for the common factors between the terms here. Okay, so we know that 3 comes out. So in other words, we're going to divide both our terms by 3. Okay, and the 3 doesn't disappear. It now comes to the front. And in brackets, we're going to put what the answers to these two terms would be. So 3x divided by 3 is just x, okay? And negative 6 divided by 3 is negative 2. And if you look, we've gone full circle. Here's the same two things, okay? So it might be hard to realize when we would use common factoring, but normally in a question of common factoring, they would give you, cut that out, I'm trying to get rid of the top part. There you go. They would just give you this and then tell you to common factor. I wanted to show you the similarities, okay? Distributing takes you to standard form. Factoring takes you from standard form to factored form, which is essentially what you'd be working with. It's full circle here, okay? So, same idea. Let's distribute quickly. I'm going to distribute this number into both of these. This is our second question. Negative 2x times negative x will be positive 2x squared, okay? And negative 2x times 4 gives us negative 8x. Now, when you're factoring, and actually let's do this first. Excuse me. Let's look for something that is divisible by both terms. Can you think of a coefficient that both these numbers are divisible by? So the actual
2.
Yeah, 2. Both of these are divisible by 2. But not only that, they both have x's. Okay, so we look for the x with the lowest exponent, and in this case it's technically a 1, and we're going to divide by that 1. Okay, so we're going to divide by 2x. So that 2x is going to come to the outside of the bracket, and inside the brackets we're going to divide our terms and see what we get. So 2x squared divided by 2x, well, the 2's essentially create a 1, and x squared divided by x is just the value of x. So we have just x, okay? Negative 8x divided by 2x, well, negative 8 divided by 2 is negative 4. And the two x's create a 1, or you can call them canceling out. So I'm just going to rewrite it quickly. 2x, x minus 4. So we've gone, in this case from here, this is our standard, to factored form by common factoring. But if you look, it looks a little different. This was a negative up here. This was a positive, and sorry, this was a negative. This is a positive. This is a positive. This is a negative. They're all kind of opposite. And the reason being is because when we common factor out, we can choose to factor out a positive term or a negative term. We're not technically wrong. If we had factored out, okay, so I'm going to start it again. This will give us good common practice here. We're going to bring it from over here again. 2x squared minus 8x. If we decided, you know what, I want to factor out negative terms. So I'm going to factor out negative 2x. Okay, it's still the same common factor. We just did the opposite operation. We'll get is equal to negative 2x. When we divide by a negative, we're going to get a negative answer, so we'll get negative x. And negative 8 divided by negative 2 is positive 4. And boom, it's the exact same, I don't know why I said that. It's the exact same term as what we had up here, okay? So here's our third example, and this would be a tougher type question. Trying to common factor here. And if you look, it kind of looks like we should be distributing instead of common factoring, right? You would think, oh, maybe I should send these inside the brackets. But I can't actually common factor this. And one way to help us out here is these two brackets. If you notice, they're the same. Okay, so that's helpful to us, but maybe I'm unsure how it's helpful. So what I'm going to do is I'm going to replace them with a let statement. You've done let statements before?
Yeah.
I'm going to say let x minus 2 equal the letter a. Okay, so I'm going to replace both of them with the letter a. So now it becomes 3a minus 4a. Now, can you think of a common factor in these two terms here now? What would come out of both of these?
A.
Yeah, we can divide both of these by a. Okay, so we take the value of a out. So we take out a, and we're left with, oh, and I should have, sorry, I'm going to make that an x, just for, so that we can't actually combine those terms. We'll make that an x. It's kind of late to do that. We take our 3x, that's what's left, and minus 4. That's in a bracket. But technically our a wasn't what we had started with, right? Our a term here is actually x minus 2. So we're going to replace a with x minus 2. So now it looks like 2 bracket 3x minus 4. So now we have two sets of brackets. So how does this relate to distributive property? Well, at this point, usually a distributive property is considered FOIL, where you take the first term and you multiply it by the first and the last, like a rainbow method, and the second term by both. Well, if I were to do that, I could technically, okay, and I'll kind of slide it over here. Let's say we take the reverse. Let's do 3x times x and times negative 2. In other words, I'm doing 3x times that bracket. So I get 3x times x minus 2, okay? And then I'm going to take the 4 and do the same, or the negative 4 and do the same thing. I'm going to multiply it by both. So we get negative 4 times x minus 2. And if you look again, computer's slowing down immensely here. But this is the same as this. This is technically distributive property. We didn't continue. We're kind of halfway through it, okay? But this is considered the hardest type of common factoring usually. When you have brackets to common factor out, it can be hard to see. So anytime you see brackets are the same, a let statement and replacing with just a simple variable is a much easier to look at. Okay, there we go.